We're going to calculate the least squares regression line for this data. This requires the computation of two quantities which we met when we were discussing correlation, Sxy and Sxx. We'll calculate these again in detail in this example. Once we have these, we compute b, which is Sxy, divided by Sxx, and then we compute a quantity called a, which is the mean of the y values, take away b times the mean of the x values. Once we have this, the regression line is a plus bx. Sxy is given by the sum of x times y, take away the sum of x times the sum of y, divided by the number of pairs of data. Sxx is given by the sum of x squared, take away the sum of x all squared, divided by the number of pieces of data. We'll see how this works in detail as we work through the calculation. To work through the calculation, it's best to construct a vertical table. We need our x values, our y values, and we're going to need x squared values and x times y values. So these are the four columns: x, y, x squared, and x times a y. The x values we read off from the table at the top: 5, 10, 15, 20, 25, 30, 35, and 40. And the y values are 98, 90, 81, 66, 61, 47, 39, and 34. Complete the x squared column. 5 squared is 25, 10 squared is 100, 15 squared is 225, 20 squared is 400, 25 squared is 625, and 30 squared is 900. 35 squared we know is 1225, and 40 squared is 1600. We now do the x times y values. 5 times 98 is 490, 10 times 90, then we have 15 times 81, 20 times 66, 25 times 61, 30 times 47, 35 times 39, and finally 40 times 34. We now need all the various sums. The sum of the x values is the sum of this column. To get the sum of the y values, we add this column. For the sum of the x squareds, we add this column. And the sum of the xy's is the total for this column. We can also see that we have 8 pairs of data, so n is equal to 8. Now calculating Sxy, we know this is the sum of the xy's, which is 9585, take away the sum of the x's, multiplied by the sum of the y's, divided by the number of pairs of data. This calculates to give us minus 2025. for Sxx, we have the sum of the x squareds, take away the sum of the x column, squared divided by the number of pairs of data. And this calculates to 1050. B is then Sxy divided by Sxx, so minus 2025 over 1050. And this calculates to minus 1.929, correct to 3 decimal places. Calculate A, we need the mean of x, which is the sum of the x column divided by the number of pieces of data. And we also need the mean of the y values, which is the sum of the y column divided by the number of pieces of data. This gives us 64.5. A is then equal to y bar take away b times x bar. So this is 64.5 take away minus 1.929 times 22.5. And this calculates to give us 107.9 to 1 decimal place. So our regression line, which is a plus bx, is 107.9 take away 1.929 x. So we can see our regression line has a y-intercept of 107.9 and a gradient of minus 1.929.